Here you see my IBM 5150 in a dual monitor setup that I picked up last week. It has the 5150 machine, the 5153 CGA monitor, and the 5151 MDA monochrome monitor. I stumbled upon the system online where it was advertised as an old computer. Nowhere in the title nor in the description did it mention IBM, so I ended up getting a great deal on it. The seller told me it was in working condition, but I didn't get the opportunity to test it when I purchased it. So when I got it home, I was really excited to get it up and running. In fact, I was so anxious to see if it would run that I just plugged in the power cord and powered it on. So I flipped the switch and was looking forward to seeing something on the screen. I hooked up my 5153 monitor onto the CGA card and saw the blinking cursor. So far so good. I know that these IBM 5150s take a very long time to boot, and you end up staring at that blinking cursor for quite some time. But all of a sudden the following happened. While it was displaying the blinking cursor, the machine shut down. So I was assuming that there was some kind of short on the main board or one of the expansion cards. So I turned off the power supply switch and decided to take a closer look. Now, as the computer was sitting there with the power switch off, the motherboard decoupled from the PSU, but only the mains cable still attached, I noticed something exploding in the power supply unit and the magic smoke appeared from the vents. Now this is obviously not a good sign, so I thought at that point that the power supply would be pretty much toast, and I hope it didn't bring a whole lot of other components with it. Now as I was examining the system further, I noticed what I thought at the time was a short between the 5-volt rail and ground. So every time I hooked up the floppy controller card, I would see continuity between 5 volts and ground. I had the same issue with the 12-volt line. So every time I hooked up the CGA card, there was a dead short between 12 volts and ground. So these are two other issues that I needed to tackle alongside the power supply. So there are three things that needed fixing. One is the power supply, where the magic smoke appeared, which is never a good sign in any electrical component. So my hopes of getting that fixed soon were pretty slim. We have the floppy controller, which gave us a short between 5 volts and ground when plugged into the system. And we have the CGA card, which caused a short between the 12-volt rail and ground. Now, in order to diagnose these issues, I decided to disassemble the entire unit so that I could take a closer look at every individual component. So I figured now is as good a time as any to give you an overview of the system. So here we have the 5150 mainboard, the first PC. This is the 64 kilobyte version, so it's maxed out in terms of memory with 64 kilobytes of RAM onto the mainboard. We have the IBM MDA card, which is the monochrome card. We have the IBM CGA card, which is the color graphics card. We have the two full height 360 kilobyte 5¼ inch floppy drives. We have an aftermarket power supply unit that failed, so this is not the original IBM power supply, but it fits the case very nicely. We have two RAM expansion cards that provide the machine with a total of 640 kilobytes of RAM. The big one here has a total capacity of 256 kilobytes of RAM, but only 192 is filled. The smaller one has 384 kilobytes of RAM, totaling up to 640. And we have the floppy controller, also an IBM card. We also have a nice Model F keyboard. Unfortunately, the guy who sold it to me didn't like the original layout, so he ended up writing a whole bunch of stuff on it. But that will probably come off. So Here's the complete overview of all the components of a 5150. So a small recap, 3 things we need to fix. The power supply unit where the magic smoke appeared, a short on the floppy drive controller between the 5 volts and ground, and a short between the 12 volt rail and ground caused by the CGA card. Now my track record of fixing power supplies isn't all that great, so luckily I had a spare. I also had spares for the CGA card and the floppy controller, giving me a good reference. But we'll start by taking a look at the power supply. So this is an aftermarket power supply which was created specifically for the IBM 5150 as it fits the case exactly. So we'll be opening it up. There are a bunch of different types of screws on here. So we'll open it up and see what's inside. Now we immediately see that there is a component here that pretty much exploded. Now this is the line suppression capacitor. It's a very common failure in these old computers, especially when these old computers haven't been turned on for a while. What you would see is that upon starting up, the machine would work for a couple of seconds and then it would basically stop working. So this is what I had on my system. So I think this kind of failure was pretty much unavoidable, and as this is a component which is on the AC side of things, I doubt that it has something to do with the motherboard or the expansion card related issues that we also saw. Now I've been told that this power supply unit can work without this capacitor, but I will be replacing it. The rest of the power supply seems good, except for a little bit of dust, so I think I will be able to recover it. But because I don't have the components at hand right now, I will be replacing the power supply with the other spare that I've got. So, issue number 2, the floppy drive controller, causing a short between 5 volts and ground. So I've decided to look at the pinout of the ISA slot, and I noticed that B1 and B3 refer to ground and 5 volts. So I would expect that there would be a short on it. Now an ISA slot has an A side and a B side. So what I'll be doing is I'll be probing the B side and see if there's a short between 5 volts and ground. And much to my surprise, there wasn't. However, as soon as I inserted the floppy drive controller into an ISA slot, I noticed that the short would appear. So something was causing this short. So having no idea what could cause this issue, I decided to look at the capacitors on the floppy drive controller, because these tantalum capacitors have a tendency to fail, cause short circuits. But as I didn't find anything on the board, I didn't seem really likely that it would have something to do with that, but I ended up desoldering them anyway and using my ESR meter to check the series resistance of the capacitor, but they all checked out fine, so yeah. Still had no clue what was causing it. I continued probing around the motherboard. I didn't find anything wrong with the caps or the ISA slots, so it was all very puzzling to me. So I decided to take a good night's sleep, and with some help from the people on the Retro Machines Facebook group and an Akabukuku YouTube video, I had an epiphany. The thing that I thought was a short due to the continuity check on my multimeter isn't a short at all. Now multimeters have this thing called a continuity test, where they will beep when there is continuity detected. Now the definition of continuity isn't necessarily a dead short. Here for example I have a 22 ohm resistor which measures 22 ohms, but when I do a continuity check on it, the multimeter will beep. And this is exactly what I'm seeing on my IBM 5150 when the floppy drive is inserted. Now I was so focused on this continuity that I didn't end up checking the actual resistance between the 5 volt and the ground rail. So as you can see, without the floppy drive, it measures about 47 ohms, which is not a lot. And when the floppy drive expansion card is inserted, it drops to 21 ohms. Now this is very little resistance, and according to the multimeter, it sees it as continuity, but that doesn't mean that it's a dead short. On to the final problem, and that's the CGA card and the short on the 12 volts and the ground. Now I'm assuming it's a short, so with the knowledge that I gained from the floppy drive controller, we're going to be taking a very close look at this. So I'm again using the ISA slot pinout to see where the 12 volt and the ground pins are. So in this case, they are located at B1 and B9. So I'll be using my multimeter to check that. And yep, we have a beep and we have 0 ohms. So this is in fact a dead short. Now here I've taken my other CGA card that I know is working, and I'm going to search what components are on that 12 volt rail. And I notice that there's a capacitor there on the top right of the CGA card that is hooked up to the 12 volts. Now when you have a card that has a short between 12 volts and ground, it's very difficult to find the actual component which is on the 12 volt rail, because everything will be pulled down to ground. So that's why it's nice to have a working card as a reference. But here the problem is going to be this particular capacitor that has completely shorted. So we'll be needing to replace this one. So I took the opportunity to see if my ESR meter would be able to detect these types of issues in circuit. So here we have the bad CGA card, and I'll be testing the capacitor here. So it is measuring some resistance, but it detects it as being in circuit leaky. Now if I take the good CGA card and I do the exact same test, you'll notice that it doesn't only find the resistance, but it also measures the capacitance. Now I've had mixed success with testing these types of things in circuit using the ESR meter, depending on how the capacitors are placed. If you want to have 100% certainty, you'll need to remove them from the circuit. Now the capacitor that has shorted has 3 pins. So in terms of polarity being important here, the minus is on the 2 outer pins, while as the central pin is the plus. So whenever you're replacing such a capacitor with a 2-pin capacitor, make sure that you respect the polarity. So this is a 10 microfarad 16 volt tantalum capacitor, and I'll be replacing it with a 10 microfarad capacitor rated at 35 volts, because this is the only type of capacitor that I have here. So now it's just a matter of putting the good capacitor onto the board with the correct polarity. So the plus goes into the central pin, and one of the outer pins can be used for the minus, so you can turn it whatever way you want, but the central pin is the positive. So we'll be soldering it onto the board, and then we will do a resistance test. So with all of the components replaced or fixed, I'll be cleaning up the case a little bit before I start with the assembly of the system. First order of business is the main board that will slide into the case. So it uses these plastic spacers that slide into the case to hold it firmly in place. And what's left is to attach these 2 screws onto the motherboard. We'll hook up the power supply. attach the PC speaker so that we can get audible feedback in case we don't get anything on our screen. I'm also going to be putting back the 5 1/4 inch floppy drives. So this is the A drive, which is terminated. So this one will go in the left bay. And then we have the B drive, which isn't terminated. That will go onto the right side. Every time I see one of these full height 5 1/4 inch floppy drives, I'm left in awe. It seems like they're so complex, these devices. When looking at the PCB, the amount of components and the amount of cables attached to them. So I'm going to be using the monochrome display adapter by IBM to test the system and see if it boots. So I'll be attaching the 5151 monochrome monitor onto it. So, moment of truth. I'm flipping the switch and I'm hoping to see something on the screen. And there we have our blinking cursor, followed by some error codes. Now it's normal at this point to see these types of error codes, as I don't have a keyboard installed, I don't have the correct amount of memory installed, and the floppy drive isn't connected. So, feeling confident that the machine will boot, it's time to add the rest of the expansion cards to the system, starting with this memory expansion card, bumping the memory with an additional 192 kilobytes of RAM. The CGA card that we fixed with the new capacitor that we'll use to hook up our IBM 5153 monitor. Our second memory expansion card, giving us an additional 384 kilobytes of RAM, bumping up the total RAM to 640 kilobytes of RAM, and the IBM floppy drive controller. That was fine all along. We'll hook up our two 5 1/4 inch floppy drives. Now the power connector for these things are located in the most uncomfortable location ever. So I have no idea why they decided to put them there. Probably due to space constraints. But they're very difficult to get to. And finally we'll hook up our floppy drive cable. So here we have the twisted cable for the A drive, which is also terminated. So we'll start with that one. We'll bring it over to our B drive, which is the non-twisted cable. And then you'll see my mad cable management skills, where I will be rerouting the cable back to the IBM floppy controller card. So with that, all that's left to do is to close the lid again and do a final boot with an MS-DOS boot floppy. So now we can start the computer, turn on the CGA monitor, wait for the blinking cursor, and hope to see an MS-DOS welcome prompt. And there it is, our fully functioning IBM 5150 starting MS-DOS 3.2. So some of the key takeaways for me in this whole experience was that, as we're dealing with very old hardware, things tend to fail. And some of these failures can be both spectacular as well as unavoidable. This component, for example, was going to fail as soon as I started the computer. It was unavoidable. So obviously I could have checked all of these capacitors up front, but sometimes you just need to wing it and hope for the best, but also expect the worst. Another takeaway for me is to always challenge and question yourself. Just because you've convinced yourself, for example, that this is a short, it doesn't necessarily mean that this will actually be a short. So always question yourself. Look up documentation. There are lots of references out there, pinouts, schemas of all of these components. So look them up. Make sure you have the right tools to do proper measurements. For example, capacitors. Standard multimeters typically don't do well with capacitor measurements. This is a fairly cheap ESR meter that you can pick up that can do in-circuit testing, that can measure not only capacitance, but also the internal resistance of the capacitor. Be prepared to do repairs on the hardware. Make sure you have a soldering iron. Practice your skills. Make sure that you're able to desolder stuff. The components that typically fail are very cheap components, and you can pick them up almost everywhere online. Very often the fixes are trivial. Try to build up a collection of hardware and spare components. These will help you a lot in debugging issues. It will give you a good reference of what a good component should be doing. Reach out to people online. Don't be afraid to ask questions, whether it's on different forums, Facebook groups, or reference sites. There's lots of knowledgeable people out there that are willing to help you out. And finally, enjoy the computer. These computers are meant to be enjoyed and used. Find the appropriate software for them, experiment with them, and share your experiences with them online. So I hope you've enjoyed this video, and if you did, please like and subscribe, because there's lots more retro content coming your way. Bye for now.